Good morning, I'm Shiny. Now I am working at the Mona College of Engineering. Now I am going to about talking name as logical time. What is logical time? Logical time is a mechanism used is a distributed system to determine the order of events without relying on synchronized physical clocks. It helps maintain consistency and coordination among multiple computers communicating over a network. That means for certain algorithms or these internal consistency for the of the clocks that matters the configuration in this algorithm to speak of logical analysis. If you have many companies called internal clock or same as physical class, not same, but that name is not important. The clock time is not important. That is that events first that is execution, then another events are next. That is the importance of logical time. This illogical times is to Lambert short clock synchronization need not be absolute. What is important is that all processes agree on the order in which events occur. A logical clock CP of a process P is the software counter that is used to timestamp event executed by a P. So that P means process, so that the happened before relation is respected by the timestamps. What is distributed computing? Distributed computing is a system of in which multiple independent computers work together to solve problems and share and resources. That means many computers, if you have one problem solved, then you have split in other computers, then overall execute the problem, then sound overall is a final output to get in the final output. Characteristics: multiple computers connected through networks. First point of characteristics is multiple computers connected through network. If you have network through the if you have six computers if connected versus network. No shared global memory that means even six computer you have even six computer can individual memories. That means not same memory, it's a individual memory. Each computer has its own processes and a class. That means each one computer has own process and clock, not a global clock, not a global memory, not a global processor. This is a own processor, own clock, own memory. Then next fourth point is communication through message passing. Communication through message passing, resource and shared among nodes. Resource are shared among nodes. How to communicate system means the system communicate through message sender and receiver. That means message passing. This is called message passing. Process are shared among nodes. How to along share the process if you use to nodes? For examples, Google search, cloud computing, banking systems, distributed database, online multiplayer games. These are the examples of distributed computing. Once again, distributed computing is the multiple dependent computers work. These are the characteristics: multiple computers connected through network, no shared global memory. Each computer has its own processor and a clock. Communication through message passing. Resources are shared among nodes. Examples: Google search, cloud computing, bank systems, distributed database, online multiplayer games. Challenges are different computers have different local class, making event ordering difficult. What is logical clock? Logical clock is the virtual clock used to establish the sequence of events in distributed systems rather than measuring actual elapsed time. Logical time is that means first which events are executing the first, that means the logical time. Purpose determine the order of events. Second one's main consistency, synchronized distributed process. Fourth one dedate Haswell relationships. Dedate Haswell relationships. These are the purposes of logical time. Why physical class are not enough? Why reason that of why physical class are not enough, that this distributed computing for clock drift. Clock drift means if you have two events, two clocks, if you want to have two clocks, if your first clock means slow, then next class if A clock is slow, if B clock is fast. So these are the called as class clock drift. These problems used to the logical clock. This next point is network delays. Network is sometimes network error, network stop, network enough. So these are the problems are network delays. Different time zones. For different time zones, for if you have clock A 10 a.m. then clock B is 10:20 a.m. So different is 20 a.m. So these problems are physical clocks. Hardware differences. There system A system can other different class system B. So these different clocks are maintain the physical class are perfect in logical clock. Impossible perfect synchronization all class. This is the importance of not enough of the synchronization of the physical class. Logical clocks solve these issues by tracking event ordering instead of real time world. Logical time. What is logical time? Logical time is the virtual clock used to establish sequence of events. Purpose determine the order of events. Maintain consistency, synchronize distributed process, detect actual relationship. Why physical clocks are not enough? Clock drift, network delays, different time zones, hardware differences, impossible to perfectly synchronize to all clocks. Logical clocks solve these issues by tracking even ordering instead real world time. These are the logical time. Need of logical. What is need of logical? Distributed systems face several synchronization challenges for problems no global clock, variable communication delays, concurrent execution, independent process. No global clock means not a common clock, even individual clock, even it's only one clocks. If you have individual clocks, variable communication is concurrent execution, independent process. Importance, event ordering, data consistency, distributed debugging, resource sharing, mutual exclusion of algorithms, distributed transactions without logical clocks. Determining which event happened first becomes impossible. These are the need of logical clocks. Lambert logical class. Lambert logical class used to introduced by Leslie Lambert in 1978. Lambert clock concept as every process maintains a logical counter. For rules 1, increment the logical clock before every internal event. Rule 2, when sending a message, incremental clock attack timestamp. Rule 3, when receiving a message, compare local clock and received timestamp. Set a clock is equal to maximum of how to set the Lambert clock means set clock maximum local comma received into +1. For formula C is equal to max local clock received timestamp +1. This guarantees consistent every ordering. Example of Lambert clock. Consider two process. Process 1 event A. If you have sent message and then event C. For if you have two process, process 1, process 2. First event means action event A send to message, then event C. Clock values 1, 2, 3. Process B receive message event D clock values maximum of 1, 2 plus 1 is equal to 3. Next event value is equal to 4. Event ordering the below execution. How to execute the Lambert clock? B1 first process, then A of 1, then B of 2, then receive the message, then D4. This ensure all events in logical order. They have to process first event A and sending messages and receiving message. First event A and event last ending event D. Vector clock. What is vector clock? Vector clocks improve Lambert clocks by identifying hash-rate relationships more accurately. Each process keeps an array instead of a single counter. For example, P1 is equal to 2, 0, 0. First value you have to P2 value 2, 3, 0. P3 value is equal to 2, 3, 1. Definition vector class is the improved Lambert class by identifying hash relationship more accurately. Each process keeps an array instead of a single counter. For example, P1 is equal to 2, 0, 0. P2 is equal to 2, 3, 0. P3 is equal to 2, 3, 1. Rules: increment one entry before every event. Send the ender vector with each message. On receiving, take maximum of each position. Increment one position. Rules: if you have a vector class, if you have known that rules: increment one entry before every event. Send the ender vector with each message and receiving. Take maximum of each position. Increment one position. Difference between Lambert clock versus vector clock. Features: timestamp. Lambert clock means single integer. At the time vector class vector of integer. Feature: complexity. Lambert clock low, vector clock high. Feature: storage. Lambert clock small, vector clock large. Feature: detect hash-validity. Lambert clock partial, vector clock complete. Scalability: Lambert clock is the better and vector clock less scalable. The feature: message size. Lambert clock small, vector clock large. These are the difference of the Lambert clock versus vector clock. Application of logical line. Logical clocks are widely used in distributed database, event ordering, transition management, cloud computing, blockchain, distributed file system, mutual execution algorithm, event line. Distributed system is the database, event ordering, transition management. How to work in cloud computing for two types: data synchronization, fault detection. These are the applications used to the logical line. Blockchain, ordering transactions, consensus protocol. Distributed file system, file version control, conflict decision. Mutual exclusion algorithm, shared resource allocation, event logging. Event logging means debugging distributed applications. These are the applications of logical time. Advantages and limitations. Advantages of logical times: no need for synchronized physical class because only synchronous process are used. Easy implementation. If you have used logical clock, implementation is easy. Ensure correct event ordering. Ensures if you have event orders correctly. Improves consistency. Supports distributed algorithms. These are the advantages of logical time. Limitations. Lambert clocks cannot detect concurrent events accurately. It cannot detect concurrent events as accurately. Better clock. Large storage requirements. Then high communications overhead. Difficult to scale with many processes. Real world examples: suppose three Pangi servers process transactions. For example, a server A deposit 500. Timestamps equal to 4. Server B receive updates. Timestamps equal to 5. Server C processes withdrawal. Timestamps equal to 6. Logical class ensure all server apply transitions in the correct order, preventing inconsistent account balances. These that means account balances are times are fixed, preventing the account balances. Logical clocks ensures all servers in the correct order, preventing account and balances. Conclusion: distributed systems do not have a global physical clock. That means logical clocks provide a way to order events. Lambert clocks are used integer timestamps. Vector clocks capture cancellation more accurately. Logical times is essential for a synchronization, consistency, and coordination in the distributed computing.